Alright, this is frames and machines, and in frames and machines you need to use everything that you've learned to solve different types of problems. And really, it just takes practice. So we're going to go through a general procedure for it, but each one is a little bit different, and you just need to try different things, and if it doesn't work, keep trying, because there's a solution. So, for your procedure, and there are a ton of examples in your book, so feel free to look through them and try them yourselves, and then look at what they did in the book, because this is one of the most complicated topics. So, first you're going to draw the free body diagram of the entire frame or machine. Or a portion of it, or each of its members, depending on what the problem is asking for. So, if the free body diagram of a group of members of a frame or machine is drawn, the forces between the connected parts of this group are internal forces, and are not shown in the free body diagram. So, this is a good example of that. So you can see this is our frame, right? And when we do both the members, you see the forces at the connection at B, right? The pinned connection. But if you were to draw a free body diagram of the entire machine, or frame in this case, you don't see BX and BY, because those are internal forces when you're doing the entire thing. So that's all that is saying. Is that if you're going to draw the entire machine, a pin connection like that doesn't have a force, but if you break it up, they're going to be equal and opposite at that pin connection, which is our next step. So, forces common to two members which are in contact act with equal magnitude but opposite sense on the respective FBD, free body diagram, of the members. That's like what we saw when both the members were drawn, a free body diagram of each. The pinned connection B was going positive in one direction on one free body diagram and negative in the other, equal and opposite. And then two force members have equal but opposite collinear forces acting at the ends of the member. Then for the equations of equilibrium, you want to sum the moments about a point that lies at the intersection of the lines of action of as many of the unknown forces as possible. And then if your solution is negative, then reverse the sense of the force of that shown on the FBD. So if you have a force shown on your FBD like this, and then you find that it's negative, the magnitude, then in reality, the force is actually like that.